Hi everyone, I hope you're doing well. Alex with Campfire here. Today we're going to be looking at a couple different properties of hot water and cold water. So this one's had some ice cubes in it that I've taken out for a couple minutes, and this one was some heated up water on the stove. And so what we're going to be looking at is actually adding some food coloring to each of them to see how fast the food coloring drops down into the water to kind of see how fast the water molecules are moving. So in each of these, there's different molecules, H2O, and we'll see which ones move faster and which ones move slower based off the cold water and the hot water. So I'm going to add a drop of red to the cold water and a drop of red to the hot water. So as you can see, the hot water is actually already catching up and passing the cold water going down. And so what's happened here is the hot water actually, the molecules are moving a lot faster. You can actually see the hot water is moving further out to the side where the cold water actually went straight down to the bottom. And again, the cold water, the molecules are moving a lot slower. So what the food coloring kind of dropped and the power of the drop kind of shot it straight down. You can kind of see there's this straight line to the bottom where the hot water actually started to go down and then it's spreading out a lot more because the hot water, the molecules are moving back and forth, and the hot water is spreading it out a lot more. Let you see this a little better, get you a close up of that. So you can see this one straight down and the bottom, it's kind of collected there. It's not spreading out versus the hot water. It went in and it immediately spread out, and that's because the molecules move a lot faster in hot water versus cold water. So the second thing we're going to look at is density, and so I still have my cold red water, and I poured out the red hot water, but I now have a clear water that I'm going to add a drop of blue into. I'm going to stir that up. So we have the hot blue water and the cold red water, and I'm going to face it down so you can see what's going to happen. And so what we're going to be doing is we're going to put this piece of cardboard over the top of our cold water, and we're going to put the cold water on top and then slide it out, and we're going to see what happens. So what I want you to do is think, do you think it's going to sit on each other? Do you think it's not going to move? You think it's going to stay kind of still? The blue on the bottom and the red on top. The blue's hot, the red's cold. Probably should have done it the other way, but that's okay. Or do you think that they're going to mix, or do you think what's going to happen? So I'll give you a second to think about what you think is going to happen as I get this ready. All right, so we have it on. We're going to start sliding it off. We have them connected. Now you can see that the blue water is slowly rising into the red water, and the top is starting to get a purple color. We'll let this go a little longer. And if you do this experiment at home, you'll actually be able to see kind of the different water rising and falling with the different colors. It's kind of hard to see with the camera, but what's happening here is the cold water is more dense than hot water, and so the cold water is dropping below, and the less dense hot water, because it's further apart, the molecules are, they're flying around, actually wants to raise to the top, and so the colors actually switch when this happens. So that's why we have purple now on both sides, because the blue hot water and the red cold water actually try to switch spots and they bumped into each other on the way, so we get the whole purple color. So I did want to show you the reverse, what would happen if we had the cold water already on the bottom and the hot water on top, to see if what's going to happen. So last time we had the hot water on the bottom and the cold water on top, and I told you that the cold water is more dense, so it sunk, and the hot water is less dense because the molecules are further apart. So it went to the top, and that's why we got the purple. So now I want you to think what's going to happen if we have the cold water on the bottom first and the hot water on the top. So the hot water is less dense and the cold water is more dense. I will get my colors right this time, so I'll put the blue in the cold water. So the blue is the cold water. I'll put red as the hot water. And same as last time with the first experiment, you can see the blue sunk straight to the bottom of the cold, and the red is actually spreading out in the hot water because of the molecules are moving and moving that food coloring all around the water, whereas the blue, the molecules are going very slow, the ice water, so it's not moving at all. I'm going to stir these up real quick. All right, so the same experiment, except the blue is cold this time, and the red is hot. And we're going to put the red on top versus the blue. So let's see what happens. Definitely works best if you have a good piece of plastic you can use. I'm using cardboard, which works okay for this experiment, but it definitely works better. All right, some of it's built in, which is to be expected. But you can see that the colors actually are staying in their same spots. And so this is exactly what we expected to happen with the cold water being less dense. And so it's sitting, or more dense, excuse me, the cold water is more dense. So it's sitting on this bottom part, and the hot water, the red is staying on top because the red is less dense. It's going to stay on the top with the molecules moving a lot faster. These molecules are a lot colder, so they're sticking closer together. In the middle and kind of just where the water intermixed when I accidentally poured some in. You're going to have a little bit of purple, but you'll have your red. A little bit of purple where I poured some in and they mixed up, but then you'll have your cold blue at the bottom. I hope you've enjoyed these experiments and you've checked out our other curriculum, and be on the lookout for more. We hope you have a great day, and we'll see you soon.